Hey everyone, welcome to the MediByte channel. As a healthcare professional, I'm absolutely thrilled to bring you today's explainer on a condition that sounds incredibly complex, but is actually one of modern medicine's greatest success stories. We're talking about hemolytic disease of the fetus and newborn. Honestly, it's a perfect example of how understanding basic biology can completely transform prenatal care. So let's dive right in and make this highly manageable condition completely clear for you.
Here is our roadmap for today's explainer. We'll start with understanding the Rh factor, then look at what Rh sensitization actually is, followed by the fetal impact. After that, we'll cover diagnosis and monitoring, treatment options, and finally, prevention and care.
All right, Section 1, Understanding the Rh factor, the biological groundwork.
So to really grasp what's going on here, we kind of have to zoom in on the microscopic surface of our red blood cells. The R factor, it's simply a specific molecule found right there on the surface of these cells in some people. Basically, it's a genetic trait. You either inherit this little surface molecule from your parents or you don't. Simple as that.
Meaning you're either Rh positive, so that surface molecule is present on your cells, or you're Rh negative, meaning it's completely absent. Now, day to day, just walking around this doesn't affect your health at all. But a biological conflict can pop up during pregnancy if a mom is Rh negative and the dad passes an Rh positive trait to the baby. Suddenly you've got two completely different blood types sharing a very, very close environment.
Moving to Section 2, resensitization, or what happens when those blood types mix.
Think of the mother's immune system like a highly trained security force, right? Step 1. During pregnancy, or actually more commonly at delivery, a tiny amount of the baby's Rh positive blood might cross over and enter the mom's bloodstream. Step 2. The mom's immune system is patrolling the area, spots these Rh positive cells, and immediately flags them as foreign invaders. Why? Because she doesn't have that molecule herself. And finally, Step 3. Her immune system kicks into gear and produces Rh antibodies. These are specialized proteins perfectly designed to target and destroy those unfamiliar Rh positive cells. This initial production of antibodies, that's exactly what we in the medical field call sensitization.
Now, hearing about this intense immune response probably makes you wonder about a super common fear. Namely, does this newly triggered immune response harm a mother's very first pregnancy?
Well, the really reassuring answer is, usually, no. Because this sensitization process, this mixing of the blood, most often happens right at delivery. The first baby is typically safely born before the mom's immune system can even mount a real defense. So the first baby is usually completely unaffected. But here's the catch. Once those antibodies are created, they stay in the mother's system. They act like permanent memory guards, which poses a pretty significant risk for subsequent pregnancies, assuming the next baby is also Rh positive.
Which brings us to Section 3, the fetal impact and the actual risks to the baby.
If those pre-existing Rh antibodies cross the placenta during a later pregnancy, they start attacking and destroying the fetus's red blood cells way faster than the baby can replace them. First off, this leads to severe anemia, meaning the baby just doesn't have enough red blood cells to carry oxygen. Then, when those cells break down, they release this yellow pigment called bilirubin, causing jaundice. In really severe cases, if that bilirubin builds up too much, it can cross into the brain and cause a devastating form of brain damage known as kernicterus. And as our sources from the MSD manual highlight, this fetal anemia can even trigger polyhydramnios. That's a dangerous accumulation of excess amniotic fluid that overly stretches the uterus. So yeah, it's a very serious cascade of events for the baby.
But here is a wild and incredibly important fact. Usually, this entire disease causes absolutely zero physical symptoms in the pregnant woman herself. Seriously, zero. Her immune system is just doing what it thinks is its job, so she feels perfectly fine, all while the fetus might be in severe distress. This invisible nature of the threat is exactly why proactive medical care and screening are just, well, they're absolutely vital.
Let's look at how we catch it in Section 4, Diagnosis and Monitoring, Detecting the Risk. Right at the very first doctor's visit, we screen the mom's blood type and look for those existing antibodies. If she turns out to be Rh negative, we'll want to test the father's blood type too. But what if the father isn't available, or we know he is Rh positive? This is where modern medicine gets amazing. Doctors can now use cell-free fetal DNA testing. With just a simple blood draw from the mom as early as 10 to 11 weeks, we can actually detect tiny fragments of the baby's DNA floating in her blood to see if the baby is Rh positive. It's incredible. And if there is a risk of anemia, doctors don't just sit around and guess, they use Doppler ultrasonography to evaluate the blood flow right inside the fetus's brain. Abnormal flow? That's a strong indicator the baby's anemic.
Section 5. Treatment options and how we help the fetus.
So if the baby is in trouble, specialists at high-risk pregnancy centers step in with some truly remarkable interventions. The primary treatment? Fetal blood transfusions. Doctors can literally deliver a blood transfusion to the fetus while it's still in the womb, usually using a needle inserted directly into the umbilical cord vein. Mind-blowing, right? They might also administer corticosteroids if the pregnancy is past 23 weeks, just to help the baby's lungs mature, and then plan for a carefully timed early delivery, usually right around 32 to 35 weeks, just to get the baby out of that hazardous environment.
Finally, Section 6. Prevention and care, stopping sensitization before it starts.
This is where we introduce our biological shield, RhD immune globulin. This is essentially an injection of specialized antibodies given to the mother. What it does is brilliantly simple. It basically hides the baby's Rh-positive cells from the mother's immune system. Because our immune system is blocked from ever recognizing those foreign cells, it never sounds the alarm. She never becomes sensitized, and she never makes her own destructive antibodies.
The timing is absolutely everything with this shield. Doctors map this out perfectly. A mom will receive a precautionary injection right at 28 weeks of pregnancy. Then, if she delivers an Rh-positive baby, she's going to get another shot within 72 hours after delivery, just to sweep up any cells that might have mixed during birth. It's also given as needed if there's any event where blood might mix early, like episodes of vaginal bleeding or prenatal tests like amniocentesis or chorionic villus sampling. It ensures maximum protection exactly when the vulnerability is at its absolute highest.
And the result of this protocol? Well, thanks to preventative medicine, the risk of hemolytic disease in subsequent pregnancies is drastically reduced. We have quite literally taken a condition that used to be a major cause of fetal distress and mortality and turned it into a highly manageable, almost entirely preventable situation. It is a massive, triumphant victory for maternal fetal medicine.
So as we wrap up today's explainer, I want to leave you with one final kind of provocative thought. How many other complex medical conditions could be neutralized with such a brilliantly timed preventative intervention? Science is advancing every single day, turning the unimaginable into the totally manageable, and the frightening into the preventable. Thank you so much for joining me for this medical deep dive. If you found this breakdown helpful and want to keep empowering yourself with clear, structured medical knowledge, please hit that like button, share this explainer with anyone who might benefit, and definitely subscribe to the MediByte channel for more insights. Catch you next time.